Okay. Okay, here we go. So with this one, just make sure we're good. 1 root 3x minus 2 root 3x is how many root 3x's? Negative 1 root 3x's. We could just write that as negative root 3x, right? Okay, let's look at this. Can I add 14 cube roots of xy minus 3 cube roots of xy is how many cube roots of xy? 11 cube roots of xy. So, guys, you're going to hear me say the apple doesn't change. That means, like, right, these are just making them like terms, this side over. That doesn't change, though, right? Don't change the apple. Okay, look at number 9. Can we add these? No, don't start doing weird things like saying, oh, I'm going to add x and 7. Then you cannot combine them. With addition and subtraction, the radical and what's underneath has to be the same. Okay, with 16, what did you simplify this piece to be? Yeah, so I just, for my video, what was your final simplification right here? 2 root 7 minus, so that was 1 root 7 or just root 7, right? Oh, negative, right, perfect, right there. That's a negative sign, it's just connected, sorry, negative root 7. Okay, number 17. Did you get that one? You got 0. Did anyone else get 0? Okay, good. You got 0? People who did their homework? Okay, awesome. All right. Now, we need to refocus on rationalizing denominators again because we did a lot last time, but I did most of the hard ones with you. So let's see if you can remember how to do this rationalization. So remember, when rationalizing first, we see if something can simplify underneath. If not, then we split it up. I'm not going to go over it with you. I'm going to let you do it. So now you would say it's not appropriate to have a radical on bottom. Ready, set, go. Rationalize this. This is not on your paper, but you could write it on your paper, so if you need to refer back to it later, you can. Ready, go. Good, yep. So, guys, pay attention so that you're going to be tested on this. So we would rationalize. We'd multiply by root 3y over root 3y. So now underneath my root on top, I have a 2 times 3, which is 6, and x times a y. And now on bottom, technically, I'm going to do it over here. We have the square root of 3 squared, and then y squared. So look, root cancels out with power, so on bottom, 3y. Some people got it right, I noticed. Very good. Try a little bit harder one, number 2. Go for it. Now, here's one thing I want to remind you of on number 2. 9 is 3 times 3. You should write it like that, because then you want to rationalize by the least amount possible. What'd you get? So at least split it up. Okay. Do you guys want more time? A little bit? Okay, it shouldn't take super. So if you've already got it, then you're probably pretty good. But some of you are a little off. So we would multiply by, listen this time, mister. So we have 2 3s. We need there to be 4 so that it cancels out, correct? So how many more 3s am I going to multiply by? I need 2 more. Now there's y squared. We need there to be 4. So how many more y's? And then we have 3 z's. How many more z's do I need? Now you have to do that same thing to the top. A lot of you are forgetting to write 4th root. Don't forget. So now on top, look. 4th root. Put it together. 2 times 3 times 3 is? Make sure you write 4th root of 18. We have an x. No other x's. We have a y cubed. Squared, and a z. Now on bottom, guys, watch. On bottom, we have the 4th root of 1, 2, 3, 4 3's. That was the point. We have 1, 2, 3, 4 y's. We have 1, 2, 3, 4 z's. Now look, root cancels out with power, and we get 3yz. Raise your hand if you got it right. Nice. Wait. So helpful? Good. That's good. What's going on here? Good. Let's try one more. 5th root. I saw a lot of you get here. This is the final answer. Check yours. I knew you could. That's why I was encouraging you to do it. Awesome. Good. Very good. Okay, all right. Hey, everybody go to 19. Here we go. When multiplying a binomial times a binomial, binomial means two terms. Look, 1, 2, 1, 2. Two binomials. You've got to double distribute and combine like terms. Let's multiply this out here. So this is a binomial. 1 times 2 is 1 times negative root 5. That times that. Yep, negative 2 root 5. Now this is where people usually mess up. Negative root 5 times negative root 5. Positive root 25. Now what we're going to do is from there say, okay, now this becomes plus 5. The square root of 25 is 5. Now combine like terms. 2 plus 5 is 7. Negative 1 root 5 minus 2 root 5 is negative 3 root 5s. Correct? And done. 4. Wow. Wait, can we combine these? No, this is connected to a root 5. This is like having like a 7 minus 3x. We know we can't combine that, right? Can't combine this either. Wait. That's just the same as doing negative x minus 2x is negative 3x. The apple doesn't change. It's the same, right? We're combining like terms. Yes. Negative 1 root 5 minus 2 root 5 is negative 3 root 5. Is that what you were asking? Or did I not? Oh, yes, good point. Yeah, I gotcha. Hey, look at 24. We knew it would be breaking the most forbidden of all forbidden rules to just square that and square that because there's a subtraction sign. So we have to write this out as 2 root 3 minus 3 root 2 times 2 root 3 minus 3 root 2. We don't break forbidden rules. If anyone's breaking forbidden rules at this point in the year, that is not good. Okay, now we would double distribute. There's a lot of 3's and a lot of 2's right here, so we've got to be really careful when doing this. Okay, 2 root 3 times 2 root 3. 4 root 9. Very good. What? No, it's 2 root 9, right? If you're multiplying. Oh, yeah. We'll come back and simplify in a minute. Good point. 2 root 3 times negative 3 root 2 is negative 6 root 6. Very good. Let's do the underneath one. Negative 3 root 2 times positive 2 root 3 is negative 6 root 6. You're doing great. Negative, right here's where people mess up usually. Negative 3 root 2 times negative 3 root 2. Positive 9 root 4. Now keep in mind, this is a times sign right here and right here. So yes, we're going to simplify the radicals that can. That's 4 times 3, which is 12. This is 9 times 2, which is 18. So now positive 18 plus 12 is 30. Now don't just look at this and say, oh, 0. Just because they're the same thing doesn't mean it's always 0. We've got to check. It could be, but it could not be. Negative 6 root 6 minus 6 more root 6s is yes. Negative 12 root 6s, right? Don't change the apple. The apple doesn't change. I said that in honors and they're like, what are you talking about? Apparently I've never said that in there. The apple doesn't change. They're like, can I even move my route? Okay, 28. Now look at 28. The instructions on this are multiply out the conjugates. We're going to see interesting things happen with conjugates. So what makes it a conjugate? Same term, but what's different? The sign in between. A conjugate is exactly the same terms. The only change is the sign in between are opposites. Let's multiply this out, and you're going to see something interesting happen. 3 root 2 times 3 root 2. 3 root 2 times positive 9. Positive 27 root 2. Negative 9 times 3 root 2. And then negative 9 times positive 9. Now look, with conjugates, this will truly always happen. The middle terms cancel out. Now look, we have 9 times 2, which is 18. Now we have 18 minus 81, which equals negative 63. Now look at my answer. Do you see how it's a whole number? There's no longer a radical. Yay, and that's kind of good for future reference. No radicals are always kind of nice. Okay. Okay, what I want you to do is do problems. Do 2 problems in this section. Make sure you get them right. Do 3 problems in the conjugate section. Ready, go. 4. Notice the problem is we have radicals in the bottom. But also notice this isn't just one term. We know how to rationalize things with one term. We just do that little trick that we've been doing all along. But now we have 2 terms. The only way to rationalize if you have 2 terms is to multiply by the conjugate, because that's the only way to get a whole number. So we would multiply by this as conjugate. That's a rule you will have to remember. So if you need to write that down for yourself, if you have 2 terms and you're rationalizing, you need to use the conjugate. So to fix this, we're going to have to remember to multiply by root 5 plus root 2 on top and bottom. Now look, if there's 2 terms, anytime, you need to use parentheses or you're going to mess up. So throw on parentheses around anything with 2 terms. And now we're going to be multiplying out our numerator, and then we'll multiply out our denominator. And we know since the denominator are conjugates, it should come out a whole number, which would fix the problem of having a radical. But the top isn't going to come out so pretty. Here we go. 3 times root 5. Okay, and then that times that. Positive 3 root 2. Now right there, that times that is negative root 50. Am I right? That times that is negative square root of 20. Now we need to simplify our radicals. 5 times 10, 5 times 2. We're pulling out a 5. Notice there's a negative sign. We'll rewrite it in a second. 20 is 2 times 10, 2 times 5. So we're going to pull out a 2. So we have 3 root 5 plus 3 root 2. Now we have minus 5 root 2. And now we have minus 2 root 5. So now we can combine like terms on top. So let's go ahead and do that. So let's start with root 5s. 3 root 5s minus 2 root 5s is how many root 5s? 1 root 5. We don't need to write 1, but yes, just making a point here. 3 root 2s minus 5 root 2s. And we know we can't combine these 2 things. So we've just multiplied out our numerator. Now let's go off to the side and multiply out our denominator, which we know better come out a whole number or we've messed up. Root 5 times root 5 is root 25, correct? Now look, plus root 10 minus root 10 will cancel out. Conjugates, middle terms cancel out. Now we have minus the square root of 4. So that would be 5 minus 2, which is 3. Now look, our radical is gone on bottom. All is good now. So there would be our final answer. Hey, are you ready to try one by yourself? Then do number 35, ready, go.
So Luke's got oh my gosh, yeah.
Good. Okay, guys, look what your top is. 2 root 7 minus 2 root 2. Then it should be plus 2 root 7. And then minus 2 root 7. Wait, where did I mess up? Oh, right here is plus 7 root 2 is what I should have wrote.
That's what I did.
Right, plus 7 root 2.
Yeah.
This is what your top should have multiplied out to be. Then I simplified the radicals. And I get 2 root 7 minus 2 root 2 plus 7 root 2s minus 2 root 7s. So then these cancel out, and then these add up to be positive 5 root 2, everybody. On top. Somebody got it right up here. Now on bottom, when we multiply this out, root 7 times root 7 is root 49. Then we're going to have plus or minus root 14 plus root 14, so that cancels out. Then we're going to have minus the square root of 4, which equals 7 minus 2, which is 5. So that was your answer, except for, can't we divide across the multiplication sign? Yep, so our final answer would be square root of 2. Yes? Marco, yes? Because you have to multiply by the conjugate. Not opposite. Conjugate means change the sign in between. So if you mean opposite sign in between, yes.
Oh.
Yes. This part? So do you get up to... Now here's what's hard is once people learn conjugates, they then think we always multiply by a conjugate. That's not true. Let's look back at this one. How would we rationalize this one? Yep, just back to regular old rationalization because there's only one term. So you multiply by, they said, 2 more x's. Now here's where people mess up though. Let me show you exactly what they do on the test. They write it like this and then they only distribute this to this, which is wrong. If you have 2 terms, you've got to use parentheses. So now it's this times the entire top. So that times 2 is 2 cube roots of x squared. Now this times this, everybody look very carefully, plus the cube root of x cubed. Because there's 1, 2, 3, which yes, simplifies to be x. Root cancels out with power. So on top we have 2 cube roots of x squared plus x, correct? Now on bottom, don't we also have the cube root of x cubed? 1, 2, 3. So root cancels out with power x. So now, so we go like this, right? True. What? No, heck to the no. Very good catch, sir. There's a plus sign. You can't do that. You can't divide across a plus sign. Way to remember that. Can't do it. Can't do it. Okay? Any questions on that? That's a valid mistake, though. A lot of people do it, but not valid at the same time. Don't do it. Okay. Okay, now I want you to finish up problems 37 through 44 right here, right now. Go.